Okay, I want to talk a little bit about 4.2 functions because we didn't quite get to that in class today. So find the domain and range from a graph. So to get the domain, for the domain, right, on the graph, we want everything that is on the x-axis. So if I take this graph and I squish it down to the x-axis, every little piece, right, every little piece, and squish it onto that x-axis there, all this stuff, I would see everything from -3 all the way to 4. So I could say all real numbers x such that -3 is less than or equal to x less than or equal to 4. So that's what I could do for the domain there. Okay, so to get the range, right? Let me get rid of this stuff so you guys can see it. Okay, to get the range, so I'll do that in purple. The range is everything, all the y values, right? So the y values start here at 0 and they go all the way up. So we're talking about all of these pieces right here. So the range would be all real y such that 0 is less than or equal to y less than or equal to 3. So the range is squishing the graph onto the y-axis, all the graph onto that y-axis, and you see that all this is illuminated there. Okay, so there we go. Let's try this next one over here. Okay, so domain. So the domain looks like it's going in both directions in the x-axis, so this is just all real numbers x. Range. The range looks like it goes y is going to be strictly greater than 0, so all real y such that y greater than 0, because the graph starts. Okay, this one's kind of strange, right? So for the domain, right? Again, we're going to look at all the x values, right? So it looks like all of the x values are okay except for -2. That's not good. We have a vertical line there. So we're going to say the domain is all real numbers x such that x is not equal to +2. Because I have a vertical line. Something is going on there. We're going to talk about that when we talk about more about rational functions, okay? And then for the range, right? So for the range, it looks like everything on the y-axis is good except when we get to 1, there's a horizontal line there. So something is going on there that we'll get into later. So the range will be all real numbers y such that y is not equal to +1. Okay, so there you go. So there's 3 examples of domains and ranges for some functions right there, right? Then we talked about, the book talks about increasing and decreasing, right? So it says on what interval for x is your function increasing, decreasing, or constant, okay? So in this example, right, these are colored in, by the way. They just look like they're open, but they're actually colored in. On this example, right, for x values that are from -3 up to 0, my function is getting bigger. So for increasing, we say it's from -3 less than or equal to x less than 0. Now notice we say less than 0 because at 0 it's neither increasing nor decreasing. So it's decreasing from here all the way to here, so from 0 to 2. So it's decreasing from when x is 0 less than x less than 2. Okay? So it's decreasing from 0 to 2, and then again it's increasing again from 2 to 4, so I can add that to here. So 2 less than x less than 4. So those are my intervals for x that my graph is increasing and decreasing. So we'll do the same thing over here, right? So my graph is increasing. Well, let's see here. For values of x, as I move from left to right, all the values of x are constantly are decreasing, right? So they're getting smaller, smaller, and smaller, and smaller, and smaller, and then smaller and smaller and smaller. So this thing is increasing never. Right? It's never actually increasing anywhere on the graph, but it is decreasing everywhere on its domain. And the domain of this was all real numbers x such that x is not equal to 2. So everywhere else, this graph is constantly decreasing, even though it doesn't look like it from here to here. But as we move from values, left to right on the x-axis, our values are constantly getting smaller. Our output values are constantly getting smaller. We can exclude this line here because that is our vertical line at x equals 2. So this graph is constantly decreasing. So it's decreasing everywhere on its domain. So I'll say everywhere on its domain. So that's the deal with that one. And then that's all I have for those two right there. Okay. Then I would talk about even versus odd functions here, okay? So even functions versus odd functions. Even functions behave as following, right? F of negative x is the same exact thing as f of x. That's in comparison to odd functions that say f of negative x is the negative of f of x. So the difference here is the negative sign goes away for even functions, stays, and gives you the output of an odd functions on odd functions. So even functions are symmetric with the y-axis versus odd functions are symmetric with the origin. Okay, and then here are two examples, right? F of x equals x squared minus 3. This is an even function, and I'll show you what I mean, right? So if I'm asking for f of negative x, let me get to math mode, sorry. And I plug it in, okay? Notice I get x squared minus 3. So f of negative x is x squared minus 3. And what is f of x? Oh my gosh, it's the same thing, x squared minus 3. So that means that f of negative x is equal to f of x, because after all, those two things are equal. That implies that we have an even function, okay? And if you look at the graph, it is symmetric with the y-axis right there, okay? Now that's in contrast to this, which is an odd function. So g of negative x, if I ask the calculator what that is, that would give me negative 5x to the third plus x. Okay, let's compare that to g of x regular. Notice it is the negative of g of negative x. So both signs have now changed, right? My negative 5x cubed became a positive 5x cubed, and my positive x became a negative. So that right there tells me that f of negative x is the negative of f of x. That implies that I have an odd function, and it is symmetric with the origin, right? So symmetry with the origin is kind of strange, right? Because you're trying to figure out exactly how far away it is, like from the origin, but it's symmetric through the origin. Kind of a strange concept. Okay, that should get you through most of the homework for 4.2. All right, good luck.